Okay. We'll try this. Okay, here we go. This is where things get different. Remember what I told you. This problem in my book is written like this. Am I going to work it like this? How am I going to write it? I'm going to rewrite it. I have to rewrite it just like you do sometimes because that's the way it was in the book. But I need to do these stacked. Now look at the difference. What makes this one different than the one we did in class a minute ago? The one we did in class earlier, the 2/3 was hanging up there by the 8. Well, I can say 2/3 minus nothing is still 2/3. But I'm taking 2/3 away from something. And I happen to be taking 2/3 away from nothing. Technically, I'm taking it away from the 8. But when I subtract fractions, it sure is nice to have a fraction to subtract a fraction from. I don't like subtracting fractions from whole numbers. That's yuck. So I need to do something to make a fraction on top of the 2/3. And when things don't work out on top and bottom in the little pictures, when you break it down in sections of subtraction before, what do? We borrowed, and you're going to borrow here. And I'm going to change the color so you can see what I do. You're going to borrow here. What you do is you go to the whole number on top and you borrow 1. And when I borrow, I borrow 1, so what do I have left? 7. Now, I borrowed 1 and I immediately give it back. I took 1, I give 1 back. The 1 that you give back is going to look like a fraction. Now, in the past, we've looked at fractions and y'all said, oh, that means 1. How do I know a fraction means 1? What does that look like? Thank you, Alexis. It's the same number over the same number. So it could be anything. It could be 10 over 10, 3 over 3, 7 over 7, 15 over 15, 28 over 28, 467 over 467. It can be anything and still mean 1. But I have to choose what I want to use. Mason, what would you use?
3.
Why would you use 3 over 3?
Because there's the denominator on the fraction 3.
Oh, y'all look right here. He's exactly right. Y'all see this 3 right here? Remember the rule is that if you want to add or subtract fractions, what must be the same? Wouldn't it make great sense to use a denominator that is the same as one that you already have there? She'll come in if she needs me. Wouldn't it make perfect sense to use 3 since you already have a 3? Guys, if a Johnny decided, okay, I want to use 7 over 7, then what's he going to have to do when he goes to subtract? He's going to have to get least common multiple of 3 and 7 to make equivalent fractions. You've got so much freedom here. Use the denominator that you've already got. Then I always like to go in and rewrite the problem so I have no questions about it. 7 and 3 over 3 minus 3 and 2 over 3 gives me 4 and 1 over 3. But you have to borrow on these.
How did you get the numerator 3?
6 minus 1/4. This time I only have one fraction and no other whole number. If the fraction was in the top, it wouldn't be a big deal. But the fraction's in the bottom. I mean, it's a good problem. You can say 6, take away 1/4 all day long. But I like to have a fraction to subtract a fraction from. So what do? I take 1 away. And what does this 6 become? A 5. And I borrowed a 1, so I'm going to add a 1 back to it, right? And what's my 1 going to look like? Yeah, because you see that 4 sitting right there? I don't want to have to get least common multiples. I want it done for me already. Here's my new problem right here. 5 minus nothing is 5. What's 4/4 minus 1/4?
3/4.
Can 3/4 be reduced any? No, it's done. I'm done. Any questions? Since I cannot say 3/5 minus 4/5, I have to do something called, make sure you write down, box, borrow, add. And a lot of times you'll hear it called the BBA. The box, borrow, add. And the whole purpose of this box is to help you remember what to do. I'm going to go up to the top. When I have borrowed before in subtraction with regular numbers, do you borrow from the bottom or from the top? We do all our borrowing in the top, right? So I'm going to do all my borrowing in the top here. I'm going to box the fractional part. I'm going to box the fractional part. I'm going to borrow from the what? From the whole number. And what's it going to become? A 3. It says box, I've done that. It says borrow, I've done that. Now it says add. I'm going to do the adding in the box. Stop. I'm going to do the adding in the box, and that will remind me to add. Because this is the step they were forgetting in the first class this morning. Everybody would go ahead and do the borrowing, but they wouldn't do the adding, and their answers weren't right. I borrowed one, I got to add one back. What am I going to add back? I'm going to add 1. What's it going to look like? Why do we choose 5 over 5? Look at these two denominators. Ooh, don't we want a 5? Now I'll rewrite the problem. The box is there to remind me that I'm adding. What is 3/5 plus 5/5? 8/5 minus 1 and 4/5. And I ran out of room, so I'm going to come up here. What is 3 minus 1? 2. What is 8/5 minus 4/5? Can 4 over 5 be reduced? Yes or no?
No.
So I'm done. Final answer. We got 5 and 1/6 minus 2 and 5/6. It's a great problem because 5 and 1/6 is much bigger than 2 and 5/6. You know, when you subtract, you always have to have the big on the top. But when you break it down in sections, can I say 1/6 minus 5/6? No. So at this point, what do? I box, borrow, add. And I box the fraction. The only point in the box is to help you remember what you're doing. I box, I borrow, and I add. And all the adding happens in the box, and hopefully you'll remember to add because you see the box sitting there. It's just a tool to help trigger your memory. I borrowed a 1, I got to put back a 1. My 1's going to be the fraction that I add to the 1/6. What is it going to look like? 6 over 6. So here's my new problem. 4 and 7 over 6, because 1/6 plus 6/6 is 7/6, minus 2 and 5/6 gives me 2 and 2/6. I can't leave it 2/6 because it's proper, but it's not reduced. Greatest common factor is 2, so I get 2 and 1/3 as my final answer. Now I want to prove something to you. I'm going to switch colors, and I want you to look up here because I'm going to prove something to you. When we worked these problems out yesterday, I'm going to prove why this is the same thing. Didn't we have numbers yesterday that looked like 4 and 7/6 as answers when we added mixed numbers? And what did we do? We took the 7 over 6 and we turned it into a what? A mixed number. It was the same thing as 1 and 1/6. And then what did we add it to?
We added the 1 to the 4.
We added it to the 4. And what did you get then? 5 and 1/6. Oh, well, that's the same thing you started with. That's why this works. Y'all can't see the red very well back there, can you? That's why this works. I can take 4 and 7/6 and go backwards, and I get 5 and 1/6. You did that yesterday if 4 and 7/6 was your answer. I know, it's okay. Today, I'm going to take